Our third concept is the concept of the perpendicular distance. So what we mean by that is, for the case of a point and a line, given a point B, we want to find the perpendicular distance to the line over here. So that's the shortest distance from the point to the line. We can do something similar for the point in the plane. From the point B over here, we want to find the perpendicular distance until we reach the plane. So how do we obtain such lengths? The concept behind this section is the idea of vector projections that we have learned earlier in dot and cross products. So A dot B hat gives us the length of projection of vector A onto vector B. That's the length underneath here as shown. The formula, magnitude of A cross B hat, will give us this perpendicular distance over here. So our aim is to modify this formula that deals with vectors into our questions about lines and planes. So for our first example, we'll be finding the perpendicular distance from this point B, 4, 6 is minus 1, to the line below it, given by this equation. So on this picture, this length L is the length we are interested to find. So to find this length L, our aim is to recreate this vector projection picture and use the appropriate formulas to obtain the length. To do that, we will make use of equation of a line. Our equation of a line gives us two important ideas about this line. Minus 1, 5, minus 3, this first vector over here, is the position vector of a point on the line. Meanwhile, 1 minus 1, 1 is our direction vector. So let's put that into our picture. So let's call this point minus 1, 5, minus 3 the point A, and we have a direction vector that's parallel to the line. So to recreate this picture, what we need to do is to join the points A and B together to form the vector AB. So to find AB, we use the formula OB minus OA. So OB is 4, 6, minus 1, and OA is minus 1, 5, minus 3. This will give us the vector AB. So if you compare these two pictures, how do we obtain the length of L? That will be given by our cross product formula. So we take the magnitude of AB cross D hat. So AB is 5, 1, 2, and D hat, the unit vector of D, is our direction vector 1 minus 1, 1 divided by its magnitude. So calculating this formula out will give us the final answer of 3 root 2. Next, we'll be trying to recreate the same approach for our plane. So when we talk about the perpendicular distance, we want the perpendicular distance from B to the plane below, as shown in this picture here. So the difference between the case of the point in plane and the point in the line is our equation of plane gives us slightly different information about the plane. Given the scalar product formula over here, r dot 110 equals to 4, what we have is the normal vector 110. So we will draw our normal vector in our pictures shortly. But before that, to recreate what we have just done in the previous slide, we probably also want a point on this plane. So what we do is we do a bit of try and error and find three numbers, find a vector such that after we do the dot product with 110, we will get the number 4. There are many options that are possible, but if we use a lot of zeros, one point that we know for sure will lie on the plane could be 400, because it will satisfy the equation of the plane. So let's put that in our picture. So we call the point A the point 400 that lies on the plane by inspection, and we have our normal vector coming out of the plane. So similar to the previous case of point and line, we will join AB together, and this gives us a vector projection picture similar to that of A and B up here. And to match these two diagrams up, we actually need to flip it. And this length L over here is actually analogous to the length of projection. Imagine the length of projection of AB onto the normal vector. So the formula of length of projection is given by A dot B hat. So the length L will be given by AB dot N hat. So we apply our formula, AB dot N hat. So AB is the vector 0, 6, minus 1. N hat, the unit vector of our normal vector. So 110 divided by its magnitude. So with a bit of calculation, this is the final result. So to summarize, for a point in a line, we find the vector AB, joining the point on the line and the point we are interested in, and use the cross product, AB cross D hat, and take the magnitude. This gives us the perpendicular distance L. However, when we work with plane, because we work with the normal vector, it's no longer the cross product, it's the dot product, the length of projection that we want. So we use the formula AB dot N hat to get the length perpendicular distance between the point and the plane.